And the factoring gets ever more tricky. Factor the following: 36 minus 9x squared. See anything wrong with this? It's a difference of squares, the way it's written. It would be better if it were in descending order. We're constantly nagging you to do that with your polynomials, so let's improve this a little bit and switch the order around. Put that out front. We get minus 9x squared and then positive 36. That doesn't look wonderful with the negative out front. What else are you supposed to do whenever you get something and you're being told to factor it? You should look for common factors whenever possible. This one has, both of these are divisible by 9, and it would be even better if you divided by negative 9, because then this leading negative would be out of the way. If you factor out negative 9, you get negative 9x squared divided by negative 9 is positive x squared. Yay, that's good. 36 divided by negative 9 makes negative 4. Okay, that's getting better. And now final step. We still have our minus 9. We're stuck with it now. This is a difference of squares, and we can factor it. X squared would have come, whoops, before I get going, plus or minus. X squared would have come from x times x. 4 would have come from 2 times 2. Done. Now here, similar issue. This is not in descending order, but we can put it in descending order. We can grab that and put it out front, and then do the plus 3x, and finally the 28. There, that's a little better. And now, because we have this negative out front, again, you have the option of factoring out a negative 1. Why do that? Well, it gets rid of this negative on the leading term, which makes the factoring we're going to do next easier. You get negative x squared divided by negative 1 makes just x squared. 3x divided by negative 1 makes negative 3x. And 28 divided by negative 1 makes negative 28. Okay. And now that we've done that, we're stuck with the minus 1 forever. The challenge is, how did we get this thing? X squared must have come from x times x. 28 could have been 1 times 28. It could have been 2 times 14. Or it could have been 4 times 7. Any idea which? We need a pair of numbers that could somehow have given us minus 3x, and we've got all the minus signs we want. These could make either 29 or 27. That's no help. 2 and 14 can either make 16 or 12, depending how you set the signs. That's no good. 4 and 7 can either add up to 11, or they can subtract to give negative 3. If you do plus 4 and minus 7, think about how you'd FOIL that. X times x is x squared. X times negative 7 makes minus 7x. 4 times x gives plus 4x. Minus 7x plus 4x gives us the middle term that we needed. And then 4 times negative 7 gives us the negative 28, so it worked. So the lesson from these is you don't have to work with the form that we give you, especially if that form is breaking conventions like the leading negative thing or the descending order thing. If you think that you can make this easier to factor by adjusting it, then by all means do that.